Hello everybody. Let's begin our discussion over the questions now. The first question consists of fill in the blanks. It says that a point whose distance from the center of a circle is greater than its radius lies in the interior or exterior of the circle. Obviously, all the points whose distance from the center of a circle is exactly equal to the radius lie on the circle. The points whose distance from the center is strictly less than the radius lie inside the circle, that is in the interior of the circle, and points whose distance from the center is strictly greater than the radius lie in the exterior or outside the circle. So here it is saying greater than the radius, that means exterior of the circle. The longest chord of the circle is what? It is nothing but the diameter. You know this, passing through the center of the circle. An arc is a dash when its ends are the ends of a diameter. An arc becomes a semicircle when its ends are the ends of a diameter. So this blank is semicircle. Segment of a circle is the region between an arc and the corresponding chord. Let's take a look at the next question. Next question says if a line intersects two concentric circles with center O at A, B, C and D, prove that AB is same as CD. I have to show this segment AB is same as the segment CD. That means their lengths are the same. If I drop a perpendicular from the center, then I can clearly see, if I talk about this smaller circle, say the smaller circle is circle 1 and the bigger circle is circle 2, then BC is a chord in the smaller circle, that is circle 1, and I have OM is perpendicular to the chord BC. Perpendicular from the center to the chord bisects the chord, so I have BM is same as MC. Perpendicular from the center to the chord bisects the chord. Perpendicular from the center to the chord bisects the chord. Moreover, the same OM is acting as perpendicular to the chord AD of the circle C2. So OM is also perpendicular to AD, chord AD of circle C2. Again, perpendicular from the center to the chord AD is going to bisect the chord AD. So I will have AM is same as MD. Exact same reason which is written over here. So I have BM is same as MC, AM is same as MD. Say this is 1 and say this is 2. Perform 1 minus 2. When you subtract 2 from 1, what do you get? You get AM minus BM is equal to right hand sides also get subtracted correspondingly, MD minus MC. What is AM minus BM? AM minus BM gives you AB and DM minus CM gives you CD. And your proof is complete that AB is same as CD based upon the result that perpendicular from the center to the chord bisects the chord. Next question says that a chord of a circle is equal to the radius of the circle. So there is a chord whose length is exactly equal to the radius of the circle. Find the angle subtended by that chord at the point on the minor arc and also on the major arc. So say this is the circle, this is the center, circle with center O, radius R, and there is a chord whose length is equal to the radius. Fine, so this is same as this is same as this. This is my chord AB whose length is equal to the radius which is OA or OB. OA is the radius, OB is the radius and AB is the chord whose length is equal to the radius. Clearly it makes this triangle an equilateral triangle. So each angle in this triangle is of 60 degrees. So this angle is of 60 degrees, this angle is of 60 degrees, this angle is of 60 degrees because it is an equilateral triangle. I am saying this chord is actually subtending, say this angle in the minor sector, or here it is written corresponding to the minor arc, and I have this angle say which is being subtended by the chord corresponding to the major arc. Because if AB is the chord, then AB arc is the minor arc and BA arc is the major arc corresponding to this chord. The angle which is subtended by this chord in the minor arc, and this is the angle subtended by the chord on the major arc. Say this is R, this is M. I have to find its measure and I have to find its measure. Clearly, if you talk about the AB arc, then AB arc subtends angle AOB at the center of the circle, and the angle subtended by the AB arc at point M on the circle, that is the circumference of the circle, is angle AMB. Angle on the center subtended by an arc is twice the angle subtended by the same arc at any other point of the circle. So angle AOB will be twice of angle AMB, because angle subtended by the AB arc at the center of the circle is twice the angle subtended by the same arc at some other point M on the remaining part of the circle. So this means angle AOB is 60 degrees, is 2 times angle AMB. So angle AMB is 60 upon 2, which is 30 degrees. So you have this angle to be 30 degrees. Now focus upon MARB. MARB is a cyclic quadrilateral. Quadrilateral MARB is a cyclic quadrilateral, and therefore we have learnt about this property that opposite angles in a cyclic quadrilateral are supplementary, right? The fact that MARB is a cyclic quadrilateral, I know angle M plus angle R is 180. This implies angle AMB plus angle ARB is 180. So angle AMB I know is of measure 30 degrees. So angle ARB will be 180 minus 30, which is 150 degrees. So this is 150 degrees. And I have found the angle which was subtended by this chord on the minor arc as well as on the major arc. Let's take a look at the next question. It says that two circles are intersecting at 2 points B and C. So there are two circles intersecting at 2 points B and C. You can clearly see that. Through B, two line segments ABD, these are line segments, mind it, ABD and PBQ are drawn to intersect the circles at A and D, at A and D and P and Q respectively. Prove that angle ACP is same as angle QCD. ACP, this angle is same as angle QCD, I have to show that. Focus upon this chord, the PA chord. Let me draw it. Let me not draw the chord, just consider this PA arc. PA arc. PA arc is subtending angle ACP and angle ABP, right? Angle ACP is subtended by the PA arc and angle ABP is subtended by the PA arc on this first circle, which is say circle 1, and say this is circle 2. So obviously both these angles are on the same segment, same side of the segment I should say. If I join A with P and consider it as a chord, then I know this complete is one segment and left out is the other segment. So the angle ACP and angle ABP both are on the same side of the segment. So angle ACP is same as angle ABP. Angle on the same segment are equal. Angles in the same segment are equal. Then I talk about this arc, which is the QD arc, or you can consider the chord also. Again, this is the segment, say minor segment. Then if I talk about QCD angle and QBD angle, both these will be equal because they are again on the same side of the segment. So this angle and this angle will be same, just like this angle and this angle were same. So I have angle QCD is same as angle QBD, exact same reason. Now QCD is same as QBD and ACP is same as ABP. This angle and this angle are same. Why? Because they are vertically opposite angles. You know that ABD and PBQ are straight line segments and they are intersecting at point B, and hence this pair of vertically opposite angles will be formed, which will be equal in measure. So angle ABP is equal to angle QBD as they are vertically opposite angles. If ABP is same as QBD, obviously the left hand sides are also same. So you obviously get angle ACP is same as angle QCD. So ACP has come out to be same as QCD. If these two are same, but because this is equal to this and this is equal to this, so these two will also be same. Next I have prove that a cyclic parallelogram is a rectangle. Now this requires properties of both parallelogram as well as cyclic quadrilateral. So cyclic parallelogram okay, so say this is the cyclic parallelogram. ABCD is a parallelogram means what? ABCD is a parallelogram means what? Opposite angles are equal in measure. So this is equal to this. This is equal to this. So you have angle D is equal to angle B and angle A is equal to angle C. This is from the fact that ABCD is a parallelogram. Now ABCD is cyclic as well. It is a cyclic quadrilateral as well. That means opposite angles are supplementary. So I have angle A plus angle C is 180 and angle B plus angle D is also 180. Now if angle A plus angle C is 180 but angle A is same as angle C, you get twice of angle A is 180, which gives you angle A is 90 but angle A is same as angle C, so angle C is also 90. Similarly, if you focus upon angle B plus angle D is 180 but B is same as D, you get twice of angle B is 180. So angle B is 180 upon 2, which is 90, but angle D is same as angle B, so these are of 90 degree measure. So you have a parallelogram in which each angle is of 90 degrees, which itself is a proof that this parallelogram is going to be a rectangle, but because this parallelogram is sitting inside the circle, therefore this cyclic parallelogram will be a cyclic rectangle. Is it understood? The quadrilateral, which was being claimed as a parallelogram, because it is sitting inside a circle, it cannot be a parallelogram, it has to be a rectangle. Cyclic parallelogram is a rectangle. Now, I have the next question as, if two intersecting chords of a circle make equal angles with the diameter passing through their point of intersection, prove that the chords are equal. Let's see. So, I have two intersecting chords of a circle make equal angles with the diameter passing through their point of intersection. So this is one chord, say this is another chord. Now I have, let me draw it again. Okay, so I have what? Passing through their point of intersection, this is the diameter of the circle. Somewhere here say is the center of the circle. Fine, this is my diameter, say AB, and this is say the center of the circle O. Fine. What is it saying? This point is say R. Prove that the chords are equal. So I have to show, say this is E, F, G and H. So I have to show EF is same as GH. Of course, EF is a chord, there is no need to extend it. You don't need to extend it, just take it as a chord. So this extensions won't be here. So you have to show that EF chord is same as in measure as the GH chord. So I have to show EF is same as GH. It is saying that these two chords are making equal angles with the diameter. So this angle is same as this angle. So angle GRB is same as angle FRB. What you do if you have to show these two chords are equal? Can you recall any result? If two chords are equidistant from the center, then they are equal. Because equal chords are equidistant from the center, and its converse is that if two chords are equidistant from the center of the circle, they are actually equal in measure. So what I do, I talk about their distances from the center. When I am taking distances, I will take perpendicular distances. Obviously, from the center, This is O. From the center I drop a perpendicular to chord HG. Say this is K. And from the center O I drop a perpendicular to the chord EF. Say this is L. I have to show, in order to show EF is same as GH, in order to show two chords are equal in length, I will show that they are equidistant from the center. So I will show OK is same as OL. How to show this? Consider this triangle KRO and LRO. So first of all, before talking about this, let me focus upon these two angles. One is KOR and one is LOR. So if you talk about triangle RKO, you know that by angle sum property, angle KRO plus angle RKO plus angle ROK is 180. Now already angle RKO is 90 degrees. Fine. Angle KOR or ROK, leave it as it is. Right? And here it is angle KRO. This is 180. So angle ROK will be 180 minus 90, which is 90, minus angle KRO. But angle KRO is what? Or rather than that, I should write angle KRO. This angle KRO was what? It is now 180 minus 90, that is 90 minus angle ROK. So angle KRO is coming out to be 90 degrees minus ROK, or I should say ROK would be 90 degrees minus angle KRO. But angle KRO is same as angle GRB. But angle GRB is same as angle FRB, which is same as angle LRO. So this is same as 90 minus angle LRO. What is 90 minus angle LRO? 90 minus angle LRO is equal to angle LOR. By exact same argument, because LRO plus RLO plus LOR is 180. Let me do that with you. Angle RLO plus angle LOR plus angle LRO is 180. Already angle OLR or RLO, this is 90, plus angle LOR plus angle LRO is 180. So angle LOR is 180 minus 90, that is 90 minus angle LRO. Fine. So 90 minus LRO is angle LOR. So you have got that ROK is same as LOR if this angle is same as this angle. You can clearly see in these two triangles, what is it that you are having? You are having angle KRO is same as angle LRO. This is given to you because the chords are equally inclined with the diameter. Then you have angle KOR is same as angle LOR. We just proved over here. And you have OR is equal to OR. Therefore, by angle side angle congruence condition, both the triangles are congruent. So you have triangle RKO is congruent to triangle RLO. And therefore, their corresponding paths are going to be equal. You will have OK is same as OL. OK is the distance of GH chord from the center. OL is the distance of FE chord from the center. Both the chords are therefore equidistant from the center and therefore they are equal. I have showed this and this implies this because equidistant chords are equal. Chords which are at an equal distance from the center of the circle are equal in measure. A circular park of radius 20 meters is situated in a colony. So the circular park is there of radius 20 meters. Ankur, Saeed and David are sitting at equal distances on its boundary, each having a toy telephone in his hand. To talk to each other, find the length of the string of each phone. So it's a circular park. After that you have, so what is the question saying? It is saying that there are 3 boys which are at equal distances on its boundary. So say somewhere here Ankur is sitting, somewhere here Saeed is sitting, and here David, such that distance between A and S is same as distance between S and D is same as distance between A and D. So this is same as this is same as this, which eventually means that this is an equilateral triangle. Fine. Now when I have an equilateral triangle, please try to understand this very carefully. This is the center, suppose this is the center. Then what happens in the case of equilateral triangle is that when you draw medians, all the 3 medians meet at the center. That means center of the circle is actually the centroid of this triangle. If this is the centroid of this triangle, then obviously when I draw the median, it is going to pass through the center because it is the centroid, it is the meeting point of all the 3 medians. So this median is definitely going to pass through the center. That is the quality of an equilateral triangle. Moreover, in an equilateral triangle, the perpendicular bisector which is dropped from any point to the opposite side is same as the median. You would be saying if the perpendicular bisector, all the 3 perpendicular bisectors if I will be drawing, they will be coinciding with the 3 medians. That means the centroid will be coinciding with the orthocenter. The meeting point of all the 3 medians will be same as the meeting point of the 3 perpendicular bisectors. Yes, that is true. Centroid will be same as the orthocenter, median will be same as the perpendicular bisector. So if AD is actually, or let me say this is M. If AM is the median, that means SM is same as MD because it is bisecting the other side, that is the property of the median. Then AM also is the perpendicular bisector, that means it is also perpendicular to SD and then bisecting it. Fine. So AM is the median which is also the perpendicular bisector. So AM is not just bisecting SD but AM is also perpendicular to SD. Is it clear? That is the quality of equilateral triangle sitting inside a circle. That the center of the circle happens to be the centroid as well as orthocenter as well as circumcenter of this triangle. So now that I have this, you know that a median, if this is the centroid, centroid divides the median in the ratio 2:1. So this is 2, this is 1. So what do you have? You have AO upon OM is 2:1. But AO is nothing but the radius. From here to here you have 20 meters as the radius. So you have 20 upon OM is 2/1 or OM is 20/2 which is 10 meters. So if OM is 10 meters and AO is 20 meters, what is AM? AM is 20 plus 10 which is 30 meters. Now consider the triangle AMD, it is a right angle triangle. I just told you this is 90 degrees, so you will have hypotenuse square is equal to base square plus perpendicular square. AM square is 30 square which is 900. MD is what? MD is half of SD, but SD is same as AD, all the 3 sides are equal. So MD I can write as half of SD, but SD is same as AD, so MD is half of AD. So MD is half of AD. And this is AD. So you will have AD square equals 900 plus AD square by 4. Now AD square minus AD square by 4 is 3 AD square by 4. This is equal to 900. So you have AD square is 4 into 900 upon 3. This is 1200. You get 20 root 3 meters as the answer of AD. If AD is of length 20 root 3 meters, then SD is also of length 20 root 3 and AS is also of length 20 root 3. So we have found the length of the string of each phone. Fine. Let's talk about the next question. If the non-parallel sides of a trapezium are equal, prove that that trapezium will be a cyclic trapezium. It will be sitting inside a circle. So I have a trapezium. It's given to me that the non-parallel sides are equal. So I am given that if the names are A, B, C, D, I am given that AD is same as BC. I drop perpendicular from A onto the opposite side. I drop perpendicular from B onto the opposite sides because AB is parallel to CD. Obviously, the perpendicular distance between these two parallel lines is going to be the same. You draw any perpendicular from one line to the other line when both are parallel, all the perpendiculars are going to have the same length. So whatever is the length of AE, same is the length of BF. If you consider the triangle ADE and BCF, you can see that this angle is 90 degree. Right? Then you have AD is same as BC. Right? And then you have AE is same as BF. So right angle hypotenuse side by RHS congruence condition, you have triangle ADE is congruent to triangle BCF. Clear? And if these two triangles are congruent, their corresponding paths are going to be equal. So you will have angle ADC is same as angle BCD. Angle ADE will be same as angle BCF. The moment these two angles are same, what do you think will be the case? Now see, because these two lines are parallel, if you extend this and extend this, you will have what? Let me extend over here to talk about these lines and extend this as well. Now you can see AB line is parallel to CD line and this AD line is acting as a transversal, isn't it? So you will have this angle plus this angle will be 180 because they will be forming a pair of co-interior angles. So you will have angle A plus angle D is 180 because they will be forming a pair of co-interior angles. Right? But angle D is same as angle C. So you will have angle A plus angle C is 180. The moment in a quadrilateral, one pair of opposite angles is supplementary, that quadrilateral is a cyclic quadrilateral. So you have ABCD is cyclic quadrilateral. We have proved this in our theory section. Fine. And so I have proved that this trapezium would actually be sitting inside a circle. All the four vertices of the trapezium will be concyclic. Let's talk about the next question. It says that two circles of radius 5 centimeters and 3 centimeters intersect at 2 points and the distance between their centers is given as 4 centimeter. Find the length of the common chord. So this is say one circle and say this is another circle. This is the center here, this is the center here, this is O1, this is O2, this is the common chord, I have to find its length. Please try to understand very carefully. If I drop a perpendicular from here onto this chord, it will be bisecting this chord. Why? Perpendicular from the center to the chord bisects the chord. So this will be equal to this, and so if this point I am declaring as M, M is the midpoint of chord AB. M is the midpoint of chord AB because perpendicular from the center to the chord bisects the chord. Now I join O2 with M. If I join O2 with M, actually what is happening? I am drawing a line segment from the center to the chord such that it is bisecting the chord, and therefore this line has to be perpendicular to the chord. So basically what is happening, if I talk about the line segment joining O1 and O2, it is bisecting the chord as well as it is perpendicular to the chord. So O1, O2 is the perpendicular bisector of the chord. Clear? Now what you do, you join this and you join this. This is 5 centimeters, here it is 3 centimeters. If I talk about the triangle AMO1, this is a right angle triangle. I just told you this is 90 degrees. Now what you are given is that the difference between the centers is 4 centimeters. If this I take as x centimeters, then MO2 will be 4 minus x centimeters. because between O1 and O2 the entire distance is 4 centimeters. So between O1 and M, if it is x, here it will be 4 minus x. So that 4 minus x plus x gives me entire distance between O1 and O2 as 4. So I will have hypotenuse square is equals to base square plus perpendicular square. So we will have 5 square is equals to x square plus am square. 5 square is equals to x square plus am square. So am square will be 25 minus x square. Let's talk about this triangle AO2M. So in triangle AMO2, again hypotenuse square is equals to base square plus perpendicular square. So 3 square will be base square, which is 4 minus x whole square plus am square. So you will have 9 is equals to 16 plus x square minus 8x plus am square. You will have 9 minus 16 minus 7 minus x square plus 8x equals am square. This is also am square, this is also am square, both these will be equal. You will be getting 25 minus x square equals minus 7 minus x square plus 8x. This gets cancelled out. 25 plus 7 gives you 32. You have 8x is 32, so x is 4. Now try to understand the situation. X is coming out to be 4. So 4 minus x will be 4 minus 4, which is 0. That means there is no distance between M and O2. There is no distance between M and O2. That means O2 is same as M. That means this common chord is actually passing through the center of the second circle. So I have actual situation like this. Say this is the first circle. Then you have this as the second circle. This is the common chord passing through the center of the second circle. This is the center of the first circle. That means this common chord, if it is passing through the center of the second circle, this common chord is the diameter of circle with radius 3 centimeters, the smaller circle. That is the situation. This won't be the scenario. Once you solve the question, you understand that M coincides with O2 because there is no distance between M and O2. They are actually a single point because the distance between them is 0, right? That means the chord is going to pass through the center of the second circle. That means it will be the diameter. And then the question says find the length of the common chord. I have to find the length of the AB chord. This is A, this is B. O2 is same as M. So AB is AM plus MB, but MB is same as AM because O1, O2 was perpendicular bisector of the chord, so it is bisecting the chord into 2 halves. AM is same as MB, so this is AM plus AM, that is twice of AM. But what is AM? If X is 4, AM is 25 minus 4 square, which is 25 minus 16, which is 9, so AM is 3. So you get 2 into 3, which is 6 centimeters. The length of the common chord is 6 centimeters, or I can say the length of the diameter of the second circle is 6 centimeter, which also is a verification of the radius. It is giving you the radius of the second circle. If the common chord is coming out to be of 6 centimeters, that means the diameter of the second circle is coming out of the 6 centimeters length. That means the radius of the second circle should be 3 centimeters, which is true. That means it verifies our answer that it is correct. Talking about the next question, it says that in this figure, angle PQR is 100 degrees. PQ and R are points on the circle with center O. Find angle OPR. Okay. Let's see. This angle is 100 degrees. I have to find angle OPR. This small angle I have to find. What I do is, I just take a random point here. Say its name is S. I join P with S and I join S with R. That gives me a cyclic quadrilateral QPSR. Because angle S and angle Q are opposite angles of this cyclic quadrilateral, they will be supplementary. So I will have angle Q plus angle S is 180. Angle Q is already given to me as 100 degrees. This is angle S. So angle S comes out to be of 80 degrees. So this is of 80 degrees. Now focus upon the RP arc. RP arc is subtending angle ROP at the center of the circle, and it is subtending angle RSP at some other point S on the circle. So the angle subtended by an arc at the center is twice the angle subtended by the same arc at any other point of the circle. So angle ROP will be twice angle RSP. So angle ROP will be twice of 80 degrees, which is 160 degrees. So this angle that you can see is of 160 degree measure. Now come to triangle OPR. I have to find angle OPR. You know that OR is same as OPY because it is representing the radius. So if I have OR is same as OP, as they are both equal to the radius, in this triangle, if OR is same as OP, angles opposite to equal sides are equal. So I will have angle OPR is same as angle ORP. Angle OPR is same as angle ORP because angles opposite to equal sides are equal. Now in triangle OPR, by angle sum property, I know angle OPR plus angle ORP plus angle ROP is 180. But angle OPR is same as angle ORP. So I will write this as twice of angle OPR plus angle ROP is 180. Angle ROP is 160. So twice of angle OPR is 180 minus 160, which is 20. So angle OPR is 20 upon 2, which is 10. So angle OPR, this small angle, has measure 10. That's how so many results culminate in one question and give you the answer to this, the value of this angle. Is it clear? That completes our discussion over all the questions. Please revise them nicely. That's it from my side. Thank you.